So, lovely humans, last session for the day. I expect we're going to get our hands dirty a little. Isaac Abraham is going to talk to us about values and functions, and he's going to make domain modeling simple. Have fun.
Thank you all for coming. Last session of the day. What better way to end it than with a F#, right? That's what we want. I think this will take probably 40, maybe 45 minutes. I want to leave some time for QA at the end. I definitely want this to be interactive. So if you've got questions, don't wait till the end. Just ask as I go. So just very briefly, who am I? So my name's not Scott Velashin. If anyone knows him, then you can think of this talk renamed as just Scott Velashin with no hair, but with a slight slant on it as well. But no. So my name's Isaac Abraham. I've been .NET dev for long enough now, but ironically more as a C# dev. I've been doing F# for maybe 6 or 7 years now, but before that was just straight C#. So anything you see today where I'm telling you how great F# is, if you're coming from a Java C# background, then take what I tell you with that knowledge that I have been doing C# for years. I'm not coming from it from Haskell or PureScript or some sort of crazy functional background. I'm probably come through a very similar journey to some of you here. So just as while I'm here, how many of you are like C#, Java style developers, TypeScript stuff, maybe like this? And how many of you are using F# today? More than I thought. Every time I ask this question, it's more, which is good. That's good. Yeah, and I'm the founder of CIT, so we're an F# consultancy based in the UK. There's 8 or 9 of us now. Our vision is basically just functional programming for everyday software. So we're big fans of F#. We don't see it, and I know a lot of people say, F#, maths and science, use it for the hard problems, but we don't really see it like that. We just use it for line of business apps, web apps, SQL databases, Azure, AWS, all that sort of stuff. So it's just another language for us that just happens to be really good. But I'm not going to focus too much on F#, the language, but more about what it can offer us from a domain modeling point of view. So that's really sort of why I'm here. It's about I'm not a DDD sort of super expert. I've gone to the usual talks and stuff, and I get it. But where I tend to focus on what we're doing is more about how we're encoding rules, how we're trying to make something that the business understands, and that ideally we can communicate with them through code as well as just talking as well. Part of the concern I've had in the past with some of our customers or other teams I've worked with is that we spend all the time doing the event storming. We do big picture, and then we do little picture, and detailed models and so on and so forth. We have great relationships, but when it gets to the actual cutting code, it almost feels like that becomes a black box, and the communication often there is lost. Who was here in the last session that was in this session, the 404? So I was worried at the start that it's going to be exactly the same as what I'm talking about now. It's not, but there's definitely some parallels in terms of how can we keep this ubiquitous language and things like this. But I'm hoping that you'll see with things like F#, you can even turn that up a notch further. So yeah, I went on to Wiki and just have a look at what is the definition of DDD, and this is like the first couple of sentences or paragraph that you get on Wiki. It's DDD is a major software design approach focusing on modeling software to match a domain. That's the bit in bold that I highlighted there, according to input from that domain's experts. The structure and language of software code should match the business domain. And then it's got here class names, class methods, class variables. So already I can sort of see there's kind of a slant towards OO. That's fair enough, that's not necessarily a problem. But to me, those 3 things are kind of weak, really. It's like, okay, name your things the same as your business use them. Okay, that's useful, but I think we can go a bit further than that as well, and actually start to use our code to actually make it a bit easier to see rules that the business have as well. I like your t-shirt. So this goes back to what I said before. I think that oftentimes we end up with black box development where you do all the talking up front, then it's like, right, I'm going to do the coding, and then I'll come back and show you maybe my BDD tests or fitness tests, or we'll do sprint reviews and daily demos and stuff. But the actual coding is kind of this disconnect between us and the business. There are two cases I found where that's not necessarily the case when you're doing OO. One is if you work in a pet store, because then you can do the inheritance hierarchy that we all learned in uni. And the other one is if you work in an art studio, I guess, and you want to draw rectangles and triangles, because then you can do that as well, right? So let's be honest, how many times have you ever thought OO and inheritance is a perfect fit for what my business is talking about? Like, come on. I'm going to go out and say this. I know not everyone will agree. Thankfully, like the lead programmer of C#, Mads Torgersen, does agree, and he said this only a few weeks ago. OOP is not the answer. I really don't think it is. You have things like design patterns, the syntax is complicated. For developers, it's not too bad. If you show a business OO classes and hierarchies and stuff, they just won't know what you're talking about. They just won't, at least in my experience. Everyone talks about how OO relates to real-world concepts. Have you ever tried to explain polymorphism to a customer? Or ask them, what is polymorphism? Oh yeah, I know that fits with how I think about things. Not a chance. And kind of the other side of it is, how do we actually validate what we're doing? We're sitting with customers, we want to show them what we've coded does what they asked for. And even the last talk was a really good example. You've got the tests running on one hand, you're writing code on the left, but don't look at the code. Look at the green tests to prove that it's working. I want something where it can be more code focused. You look at the code and you know this is doing what I want. This is encoding rules in with types rather than having to run the app, run tests and so on. Why do I want to do that? Well, I want to keep this customer collaboration going through the whole cycle if we can. Or, I'm not talking about teaching customers about distributed systems, but at least when you're modeling, sketching out domains in code that you can show them it, you can talk with them. I gain confidence by doing that because I'm talking through rules that I'm making. They can see the code and confirm it's right or wrong, and they hopefully feel more empowered because they're involved throughout the process as well. So just a few points on F#. This is the last one I'll talk about it, but just in case you've never done it before, it's a general purpose programming language. It runs on .NET and .NET Core. It's got a relatively simple set of core features that you'll use 80% of the time. The other 10-20% of the time you'll fall back to some other features. It's super readable, and it's got a powerful and expressive type system. So it runs on .NET. If you're using .NET today, you can start using it tomorrow. It's built into the .NET installation. So, a few points I want to cover today then. So, types, effects, functions, and feedback loops. The last bit will be a real-time demo of me actually coding so you can get a feel for what I'm talking about, but the first three will just be slides of me showing some code, talking about it. Basically just how we model domains, how we deal with effects. By effects, I'm talking about things like data might be missing, data might fail. We might have to make an I/O call to the network to get some data, those sorts of things, and functions, so just doing stuff. So I thought the best way to start this, and I spent too many hours actually trying to find a decent domain, but I ended up with something that I know from my time living here, which is, imagine you're a consultant and you've been hired by Deutsche Bahn, and they want you to implement a new booking and inventory system. And they've given us some requirements, and we've got to try and model them. And it's pretty simple stuff, but hopefully it just gives you some idea of how a domain might evolve, how we deal with stuff, what you might think about doing, and how you might solve it with a language like F#. So I think I've got 5 or 6 scenarios here, where we start with something simple and then we add in different sort of aspects or requirements. So this is the first one I started with, which is every train journey has its own ID. So, ICE 285, 285, whatever. And a journey is made up of stops. So you've got an origin and a destination, and you've got some stops in the middle. Yeah? And hopefully the train comes at the arrival time. Let's pretend, all of us that live here, that always happens. And every train's got a number of carriages, starts at 1 and goes upwards. So fairly simple. Now, I'll show you a couple of types in F#. So this is some F# code. And I'll start at the top. So we've set a stop, and I'll just go back there. Has a station name and an arrival time. So I've said a stop, has a string, so that's the station name, and a time. So time only is a .NET type, it's relatively new. but it's basically just a time part of a date time. And then a train, so this is a record in F#, and I've said each of those things that we needed to model are just fields. So we've got an ID, which is like the ICE, the number, a list of carriages, a start and a stop, and some destination stops in the middle. So that's, in effect, the things that we model. Now, for those of you that are doing C# and Java, you can think of this as a class that has a constructor that needs all of the fields, and it's immutable by default. And it implements things like we spoke about value objects in the previous talk. So if you have two trains and you compare them to one another, by default, it will compare every field and make sure that they're all exactly the same. So you get that kind of for free. The top thing is called a tuple, so string and time only. And the bottom is a record, where you can do the same thing, but it's with names. The important thing here to understand is that this represents like and. ID and carriages and origin destination and some stops and destination. And the top is the same thing, string and time only. Yeah. Fine. Here's how you create an example of one of those in F#. So field equals value. Pretty simple. We don't have to worry about constructors or anything like that. Everything is just basically that. So there's an example of a train from Fulda to Berlin, takes roughly 3.5 hours. Very nice. You could almost think of this as a class. So for those of you that are doing OO, it's a DTO, if you will. Except if you're using most languages with C# or something, you'd probably have to use the resharper thing to generate all the equality for you. If you're using modern C#, you can use a record. It's pretty similar to this. But I'm not so happy with this. And in this case, it's kind of a similar journey to what we went in the last talk. So I think we can do better. If I go back to the previous model, what we started with, we've got an ID, which is a string, and we've got a station name, which is also a string. But they're not really the same thing, are they? But we're modeling it in terms of here. According to the type system, they're both the same. Carriages is just a list of numbers. Yeah, doesn't really do it for me. So in F#, we can create value objects, in a sense, very, very cheaply with what are called single case unions. So at the top here, these three lines, you can think of these as like wrapper types. So a carriage number actually is an integer, but it's a kind of a wrap type. And the same here, train identifier. It's a train identifier that has a string in it. Station is the same. And then essentially what we can do is to replace everywhere we use those primitives before with specific sort of these types that we've defined. And suddenly now it becomes a bit more readable. So you can see more at a glance now what actually are these things. An ID is a train identifier. We could also put in some validation or some invariants that we wanted. So we could say, right, to create a train ID, it must start with ECE dash or something like this. So we could almost make that like a constructor, if you will, on the train ID. I'm not going to show you that here, but it's super cheap to do. You can basically just create some functions that when I create a train ID, it must go through this validation check. But again, it's just one screen, a few lines, and we've now got sort of a more complete type. The other thing that you get by doing this, and it sounds obvious, but you can't accidentally mix and match the fields. So if you think back to where we had here, I could accidentally switch in the ID for a station name. And the type system can't help us. But because now we've told it a bit more about a domain, if I was to try and mix them up, so to mix the origin, for example, with the train ID, it's going to complain now and say, well, hang on a minute, they're not the same type anymore now. You can't accidentally mix and match. So just, that's a sort of more of a developer concern as opposed to the sort of talking with the business, but it helps anyway. Kind of observation there, types are useful. They're pretty cheap to make, or they should be cheap to make. They act as documentation, pretty nice to do, and you can use them to enforce rules quite quickly and easily. So avoid these kind of domain types with just strings and ints and things like that. Use wrappers, it's easier to work with. Second scenario I had here was, right, so beforehand we had carriages as just a number. Let's say here, though, that a carriage can be either the buffet car or a passenger car. And a passenger can be first or second class. And the buffet cars can serve hot and or cold food. All the cars, including the buffet car, can have features like Wi-Fi, quiet cars, toilets. And the passenger cars have to show how many seats are available. It's pretty basic stuff. How would you model something like this in the OO world? I want to model like that a carriage can be either a buffet car or the passenger car. What would you do? I mean, literally, has anyone got any ideas? How would you model this in a class? Would you do something like this? I've got a carriage, and then I've got to capture both the information here, the buffet car info or the passenger information. Maybe we'll leave them both as nullable, so that if it's not the buffet car and it's a passenger car, then we just don't touch the other field. Check before you touch it, so it's not null. Do the right thing. What do people do? Yes, exactly. That thing we spoke about before, except no one does it, but that is the proper way you do it. You'd have a base class, which is carriage, and then you'd inherit from that, and it'd have a buffet car carriage and a passenger car carriage, and then you'd have a method on it that does any of your domain actions, and you'd inherit with virtual methods and abstract methods. In reality, very few people do it. If you do that, your customers will again, maybe they'll get it, maybe they won't. Plus also, if you're following best practices, and I did hear this mentioned in the previous talk, you must have a separate file for each of your classes, right? Because that's how we develop. So you'll have now 3 files, one with your base class and then 2 with your subclasses on them. This is wrong, though. If you do something like this, you're basically saying you have actually both of them, and they can both be blank, or they can both be filled in, or one or the other, but just make sure you do it right, sort of thing, which to me that doesn't really make sense. This is how you do it with union types, which is a feature that F# has. I think it is coming to C# one day soon. Java, I think, actually has it now with what I think they call it case classes. But essentially, I can say, well, a carriage can be either, and that's what that pipe is, a passenger or a buffet cart. And if it's a passenger class, then it's got this thing called carriage class underneath it as kind of the payload of data. And what's that? Well, that's a first class or second class. And that's got the number of seats in it. Otherwise, it's a buffet cart, and I've just put it in line here, but it's got 2 booleans, is it cold or hot food? And we could clean that up later. But this is a very different way of modeling now. These represent OR cases built into the language, one or the other. This is either or. So when you're talking with customers, and they tell you this, well, it could be this or that. That's basically a 99.9% user union type that fits exactly what they're asking for. And just so you can see how it would look at the end, so we've got a carriage, and instead of having the 2 fields as we had before, we just have one now, which says it could be one or the other, this carriage kind. It could be passenger, or it could be the buffet cart. But you don't need to have both of them now. And when we access it, you don't have to worry about have I done it right or wrong in terms of the null checks. So the compiler will help us here. So when we're looking at things like, if I try and access the first class or the second class properties on the carriage kind, the compiler won't let me. You can't do that unless you first check. So I can say here, match on the kind. If it's a first class passenger, then get the number of seats. If it's a second class, then get the number of seats. If it's buffet, then there are no seats to access. So the compiler here is actually protecting us from doing the wrong thing and helping us do the right thing. Okay, good. Right. Let's just sort of recap on that one. So OO, you can do this and stuff really, really well. DTO's perfect match for that. What it can't do so easily is the OR style of things. This or this, mutual exclusion. You can use inheritance, as the person rightly mentioned there. Most people don't, or they just think, well, let's not bother with it. We'll just have these 2 types and make sure we do the right thing. Union types, perfect match for this. Relatively easy to read. You can talk through with your business and actually see it actually building over time. And we'll see that later on if I've got time. Let's look at another scenario now. I want to record that some trains change their driver during the journey at a certain station. So you know that time when you're on the train, you're waiting for like 10 minutes and it's just sitting there. The driver's late, basically. But we have one of these per journey. So again, challenge here is how do we model and reason about data that might or might not be there? Optional data. How do we do this today? How do you do it in whatever language you're working in? Nullables. If you're lucky and you're using like a struct type or a value type, if you're using a reference type like a string, then it's like everything is nullable, right? unless you're using like new C#, which has its own problems. But let's assume we said, right, we'll add another field here, which is the driver change. And that's the station that the driver's going to change on. And if it's none, if there is no change, I'll just not fill in that field when I'm creating the record. I'll just leave it as blank. Except F# won't let us do that. I'm trying to create a train here, and I get an error. No assignment given for field driver change of type train. In other words, the compiler will not let us create half an object. Either you create it all, or you don't create it at all. So how do we model this kind of optionality? Well, pretty easy. F# has a thing called option. And you just put that at the end of the thing, and now this field is what we call optional. So it's almost inverting what we might be used to, where everything is optional, and it becomes somewhat harder to make it mandatory. In F#, everything is mandatory unless you say otherwise. And now we can essentially just use none here. So we're explicitly saying there is no driver change. So it kind of flips the coin, if you will. And you'd be surprised, 99 times out of 100, you're working with mandatory types, and then you put in optionality as an exception. You know, this is a time when I need to deal with that. You can't do things like just compare a value with an option. So I can't say, here's a station, and here is an optional station, let's do something with them. You can't plus them together, you can't compare them. They're different types, they're different values. What we have to do is pattern match on it, like we saw before. So here I'm saying, if there's a driver change station, then do something with it. If there isn't, I can't do any comparison, check it, or whatever I'm doing here. So again, the compiler trying to help us to do the right thing, but also makes it easier to read from the user's point of view. This is an optional bit of data. Question? Oh, just stretching your arms, okay. Right, okay. Again, I'm just going to skip through this, but essentially, options are basically how we model this kind of thing. The nice thing in F# is options are not some sort of special thing. You can create your own kind of types like that super easily. It's not like a custom feature of the language. Let's see how much time we've got left. Oh, we've still got time. Good. So let's have a look at a couple more scenarios, and then we'll move on to some more fun of watching me fumble around coding. We allow customers to reserve seats for trains which are not yet confirmed as running. So we've got a train that we're planning to do in 3 months' time, but it's not actually definitely in the timetable, and this is nothing that Deutsche Bahn really do allow, as far as I know. But let's say you could log in and reserve a seat on a train that's not, it might be cancelled, sort of thing. And every day we run a batch process, and it's going to go through all our trains that are unconfirmed and say which ones are confirmed and email them to all the passengers out there. Your train is now booked, it's confirmed, we've taken your money. So what this is really saying is sometimes things evolve over time. Like a train goes from unconfirmed to confirmed. And how do we deal with that? And more than that, how can we ensure that we never notify customers or passengers of a train that's unconfirmed? We want to enforce that we're not going to call this function or this batch process with a train that's actually not confirmed. We don't want to take their money, sort of thing. So here's one way you could do it, and I'm using union types, but you could do something fairly similar in an OO mechanism. So the top here is just a function. Just imagine notify passengers as a function. And this signature says, give me a train, and I'm going to do the work of notifying everyone, and I'll give you a report or a result at the end with the list of all the passengers who we notified and what time they were and what their email address was. And then in here we've got a function that says, give me a train, and I'll do the notification. So I'll check the status of this train. And if the train is confirmed, then I'll call notify passengers with that train. And if it's not confirmed, I'll do something else. Maybe I'll just do nothing, sort of thing. Yeah? The problem is, with this sort of approach, is this is unsafe. If you look at the signature at the top there, it's saying any train can be called. Whether it's confirmed or not is irrelevant. Yeah? If I've got a train, I can call it. And as a development team, make sure you never do this. Always check this field first. And if you do it wrong, we'll have sent out some emails to passengers and taken their money. Big deal. So you can actually change this and fix this. So what we could say is we make a new value object called a confirmed train. And that kind of wraps around our normal train. Think of that as a wrapper. And instead of having our notify passengers function, as we saw before, which takes in a train, we'll say it takes in a confirmed train instead. Only trains that are confirmed that are running can be sold. So it's in effect saying that now we've got a contract here that only confirmed trains are allowed to be used in this function. We can't just pass in any train. So if you even try to give a normal train in here, it won't compile. Confirmed trains are a different type. We've now made it more of a rule. You can show this and say, right, only these trains are allowed to work with this function. And then what we do is essentially have a kind of a validation function or something. So imagine here, we wanted to check the status of a train. Instead of getting back a Boolean or some sort of status, you get back one of these new guys, one of these new value objects. So this is almost like checking maybe an inventory system. Is this train confirmed as of yesterday? And if it is, we'll give back a confirmed train. If it isn't, we'll give back nothing. You won't get a value back, which means that you won't be able to call this notification passengers function. So what we essentially have at the end is this optional data, again like we saw before, but the only way you can call this notify passengers function here is with this data that we got back from our function. You can't just use any train now. So you can make invariant rules, business rules, that essentially say, only do this code if this type comes back. If I don't get the value back, I can't call it. I don't have a valid type here. So we're almost enforcing rules through types. It's not just if-then checks, where you could forget to do that. We're actually using the types to help guide us, say you can't call this function unless you get one of these back. Okay. So we can use types to actually, again, make it more like a gatekeeper. You can't call me unless you've got the right type. And you can only get one of these types if you go through a certain function that's doing the proper validation. The actest form of documentation, you can say what the prerequisites are. The main point here is just don't rely on like having a Boolean flag and telling everyone, check this flag before you call this function, because you know that some developer will forget it and it won't work. So rely on the type system to help you. I'm going to just to look at a couple more scenarios and then move on to the coding. So this one is just about effects that I touched on at the start. These are kind of 4 things that I hear often from customers when I'm talking with them and trying to understand what's going on. Things like data is not always present, and you sort of have to read between the lines when they say stuff. You know, is it always going to happen? What if it's not there? Sort of thing. Data is not available locally. Maybe we need to make a network call. This might not always work. Maybe you're calling another service and it's down, or maybe the user's entered bad data. And maybe you get more than one bit of data. And how do we model these in F#? And can we do it that doesn't change everything we're writing, that we can do it in a fairly succinct way? So I'll give you a few examples. So imagine we had a function called getTrain. And signature is pretty simple. Give me a train ID, and I will give you a train back. Yeah, so some repository, if you will. What if we wanted to say, well, that train might not exist. Maybe the train ID isn't valid, or maybe the train's been deleted, or whatever. Well, we just put option on the side there, yeah? And now we've got this effect of optionality built in. But what if then that was, let's say it was a network call. To call this function, try get train, it was going to have to make a network traffic call, and we wanted to do this asynchronously. Well, now we just put the word async on the side, and we can compose these two together. So this will asynchronously maybe get me a train back. What if we wanted to get back a list of trains? So you give it some search criteria to find available trains. Whatever that search criteria is, doesn't matter. We'll get back a list of trains asynchronously now. Again, just different effects, different ways of working with the same bit of data, but just variations on it. What if something might fail? So I want to try and create a booking. Here's a create booking request. It will give back a result, which is either success or it's failed, which is an error case. And if it's failed, what is this create booking error? Well, that's pretty easy. That's just a union of the different types of things that can go wrong. Maybe we've spoken with the customer about this. What can go wrong in this case? How would it work? You've got all these now encoded in your type system rather than just raw strings that you can't reason about. Yeah, we can actually start to use these and maybe have different handlers. If it's a save error, maybe we'll fail fast. If it's a network issue, maybe we'll do a retry policy. But we don't have to just check exceptions. We can actually deal with these properly now in code. Okay. I'll do one more, and then I think we've just got time for a bit of coding. So our staff need to make bookings on behalf of customers. Customers give us the train they want to go on. We're going to make the booking on the train for the customer and then print out the booking. So this is more about a workflow. I've got 2 or 3 different things I need to do in a sequence of steps. And I've put them in bold and scribbled a red line underneath them. So this is a fairly simple workflow. Load a train, get the train out, pass it into my booking function to make the booking, and then with the result of that, call my print booking function. Again, can non-technical people understand that? Yes, pretty sure they can. Let's see how we might encode this in types. So we've got 3 functions, and let's see what they would look like. Something like this, I guess. So load train, sort of what we saw before. And let's assume for now that we don't have to worry about options or results, just to keep things simple. Given a train ID, get back a train. And then when I want to make a booking, I take in the passenger details and their train, and I give back a booking confirmation. So this syntax here is basically just think of these as 2 inputs, and that's the output. And then the last one is our print booking, which says give me a booking confirmation, and I'll print it out and give you a printed report. And you can see sort of these line up. So the output of the first one is the input of the second one. And the output of the second one is the input of the third one. So you can sort of trace this to follow there. The problem is, and this is not just this isn't a functional thing, has anyone seen code like this where you put the thing on that you start with on the right, and then that goes onto there and that goes onto there? Has anyone done this sort of stuff before? Yeah? Now, if we were writing in Arabic or Hebrew or something like that, where they do it right from left, that might make sense. Doesn't make sense in English, or even German for that matter. So this is not the real workflow, it's backwards. So in F# they introduce this thing called pipeline, where you can do it the way that makes sense. So I want to load the train IC284, that goes into make booking for Isaac, and that goes into print booking. So it's the same thing, we've just inverted it instead of with the parentheses. And you could even do it vertically if you want, so you have this nice sort of vertical pipeline. You don't have to sort of do anything in F# to make this happen. This is just like built into the language that you can pipe any function into another one, so you can just make these chains of functions that just work out of the box sort of thing. That arrow, it's actually just pipe and right arrow. It's just I'm using a ligature font that makes it look fancy. So point there more is that workflows should be readable. They really should reflect the logical flow, something that someone can see without too much work. I haven't shown it here, but you can also use like options and results to pipe them into data and deal with those effects as well. I won't really bore you too much with the details if you want to talk to me afterwards, but there's basically, you put in a couple of functions alongside these to deal with things like results or options, and it just works. So the last thing I started with was this kind of, what's the development cycle like though? How would we sit with the business and actually show them the stuff without doing unit tests and stuff? So I want to switch over to VS Code and just show you the same domain effectively that I have just been talking about, and just show you what it looks like for real, how you might work with it and so on. Unless anyone's got questions about the slides. Good. So let me just make this a bit bigger, otherwise this will be a kind of a dull session. Right, big enough or bigger? Good, okay. So I'll just move down a little bit. So this is essentially the entire domain really that we just looked at. We don't have multiple files, I've got the whole thing in one file, and if I start at the top, we've got features, and then I've got these carriages, and the carriage numbers, and the train IDs, and the value objects, but the whole thing is what? 40 lines of code, maybe. to do all of the stuff that I've just spent the last 40 minutes talking about. It's not a huge amount, and it's the sort of thing that you could start at the bottom and work your way up without too much difficulty, in my opinion. And I've done this with customers, sat down, oh, wait a minute, origin is actually optional or something. Once you've told them the sort of the core rules, they can normally get this sort of thing pretty quickly. Now, what is nice in F#, is anyone here using things like linkpad in C# or anything like that? Okay, so F#'s got this thing called a REPL, where I can basically write code and then execute it and see the results at the bottom. So I'll move it to, yeah, let's put it on the side. I'm going to risk it now. Let's see if I can do it. No, maybe I'm not going to be that lucky. Oh no, we don't want to do that. That one there? Yeah. No, that makes another instance on the right-hand side. It would be too easy to do it like that. Wait a minute. Here we go. There we are. Okay, so let's do it side by side. So you can almost think of this actually, it's kind of a nice parallel. Instead of having unit tests on the right, which is running my code continuously, I'm actually going to be writing code on the left and then seeing the results on the right. So I've kind of just executed all my types, and I can start to just experiment with them. Like, let's say I wanted to create a first class object. I can say first class equals first class 25, which is the number of seats. And I can execute that, and then I get the value down at the bottom here. So I could start to use that in a function or something later on. So I'm writing code, but almost doing it as I go. I can see the results and start to experiment with it as well. So I don't have to stop, rewrite a console app to do something. I can just play around with data, load in stuff from an external file or something, and see what I get. And then I've written a bunch of functions. So these are things like calculate the availability of a train. How many seats are left? So I've said here that the availability can be standing, busy, normal, or empty. And I'm adding up all the seats in the train. And if the seats are 0, then it's standing room only. If it's less than 10, then it's busy. Less than 50 is normal. Otherwise, it's an empty train. And you've got all the seats to yourself. And we can do the same sort of thing with other functions and so on. I'll just show you an example of how this might look. And again, this is just to show you that you can write some functions and then start to execute them and play around with them and see what happens. So I'm going to just compile that whole module, and now I've got all my functions as well. And then I've created a fake train in memory. So this is just, on the left here, an example train. And it's literally just everything we saw before. So we've given it an idea of ABC 1, 2, 3. Here's a list of different carriages, the origin and the stops and so on, so fine. And you can see here, all of this thing sort of makes sense. So the kind is a passenger train, which is first class. And this one is a buffet car. And because it's buffet, we don't give it first or second class. It has to have these hot and cold food things. So the types all sort of add up. They all make sense. And once we've got it, we could start to play around with this. So you can imagine sitting with the customer and saying, right, let's create this train. Let's try it with some functions that we've just made, some of these domain functions. Does it work? So let's have a look at an example here. So I've got here, for example, a function called find carriages with a feature. So I want to say, show me all the carriages that have Wi-Fi. And I can execute that, and it shows me here, well, these are the list of carriages. Only carriage number 1 has Wi-Fi. But let's actually go back and just prove it to ourselves. So let's actually add Wi-Fi into the second coach. And then recompile that, and then try that again. And now we'll get back 2 carriages. So you get 1 here, it's just wrapping it over, and then 1 over there. This is the sort of cycle that I want to see with customers. Rather than them seeing, go away, I'm doing my thing. You're not going to say go away, but you know what I mean? It almost feels intimidated to ask them, have a look at my code, it's crazy OO stuff. I want to be able to show them, like, here's some example data, does it look right? Let's try a function and see what happens. Just as an example of how you might change a domain in real time, and I think I've just got enough time for this, this is actually something that someone asked me when I showed them this model. So we've got first and second class coaches here. You can see it on lines 13 and 14. Someone actually, did Deutsche Bahn still do this where you have the split coaches? And if you sit close enough to the first class, you get the free Wi-Fi? Or yes? Okay, good. So let's say we've got this new requirement now. It's not just first and second, but it's also split coaches. So I need to make a new type of carriage class. So I'm going to call it split. And I'm going to give it 2 numbers. So that's the number of first class seats and second class seats. Now what I just want to see is what is broken, what's gone wrong, where am I getting warnings in the type system that it's going to tell me, fix these rules. You've created some functions, but you're not dealing with all the cases yet. And at this point, I don't even need to look at the interactive. I can just literally fix the errors as they come. So I'm going to scroll down and have a look at my functions. And let's just maximize all of this again. Collapse. Oh no, what is it? Fold. Unfold. Right. So if I scroll up, you'll see that we start seeing some warnings. So this is one. So this is a function that says calculate the availability. So previously, I was calculating, well, if it's a buffet car, it's got 0 seats. If it's a first-class carriage, and calculate those seats, the compiler's smart enough to know that I've not dealt with this new split case. And if I scroll across, you'll see it actually gives me the exact answer. You've not dealt with the case where it's split. Please deal with that now. So I can actually go in here and actually fill that blank in. So I can say for passengers where it's split, and that's got first class and second class seats. Now I want to add them together. First class plus second class. And then I close the parens off and hopefully that all goes away. Nice. And the same thing down here where I've got seat reservations. So this function wants to try and reserve an economy seat for me. Again, warning here, you've not dealt with the situations where you've got split trains. And again, the compiler's smart enough to know that if I fill in some of these options, it will keep going until every single combination of all the union types is filled in. So I don't have to worry about accidentally forgetting one case or not. The kind of the thing to take away is the more types you build in, the more the compiler can help you because it understands more about what you're trying to do. Yeah, so not only is it easier to read, but it's easier to maintain. You can see what the implications are very, very quickly. Just so you can see other things again, like I showed you before, so we've got different errors here. So imagine we wanted to reserve a seat. What are the different things that can go wrong? Well, maybe in this case on line 84, there is no carriage. You've requested carriage 2, but there is no carriage 2. Yeah, so in the previous session, we saw someone was using like the exclamation mark to sort of turn off the type system. I don't want to do that in F#, so I'm using this function called try_find. Try and find me the carriage, but it might not work. And if it doesn't, give back nothing. And if that comes back with nothing, now give back an error called no such carriage. If you look at the type system, the actual signature there, let's see if I can zoom in on this a bit more. I know I've only got like 2 minutes left. Let's just see if this works. Yeah, okay, that's quite big. But if you just look at that function, that's exactly what I was showing you before in those examples. If I just move my mouse away from the IntelliSense, there we go. So look, this is a function that says, give me the carriage number you want and the train, and I will give you back a result. Either the new number of seats or a booking error. And what's a booking error? Then I can just scroll up and see all the different errors that can go wrong with this function. So it's kind of a documentation system that's actually real code. And you can talk with the customer, are these all the errors? Have I missed out something? Let's actually build that into the type system. And you don't have to worry about new classes. It's just one line at a time. Yeah, okay, good. I think we're just about out of time. So what I would say is come catch me after the session if you want to talk about this and is this real? I can promise you we're doing full stack web apps with JavaScript React front ends in F#, with F# on the back end as well, connecting to SQL, Cosmos DB, we're using it in Azure. This is not a maths and sciencey language, but you can get all the benefits of these kind of things in your domains with your real customers right now, sort of thing. So it's really, really good. Basically, one of the things that I like is all my devs love F#. So it's they don't get bored with the language, they feel much more productive, they enjoy it, and we can speak with our customers more. What I'm showing you now is not like make-believe. I've literally sat with customers, started with nothing, and said, right, let's sketch out for the next couple of hours something that reflects your domain, that gives us a bit more of an idea than just what we spoke about with the sticky notes, where often you'll get quite far with it, but when you start putting it in code and writing it with real data, you suddenly see, oh, what you thought was always there is not always there. What should we do when you don't have this data? That's a real business case that we need to deal with. F# helps bring that to the front and help me actually deal with these things now, rather than after we've gone live, when we run it with real data and then you realize, oh no, we don't have the data, the live data is not working, sort of thing. So it helps encode a lot of those rules. I will just add in one slide in real time now, just with my email address on it and Twitter, just so that you've got it. So if you do want to catch me on Twitter, then it's Isaac Abraham. If you want to email me, then it's isaac@compositionalit.com. I think we have 10 seconds for questions. Go. Okay. Thank you very, very much.